Okay, we're going to look at how to find the end behavior of a polynomial. Okay, so when we're trying to find the end behavior of this, when we're looking at this, we could look at the graph. And I'm not going to graph this perfectly, but I'm just going to make a sketch of it. And I know 2x squared is going to look something like that. And really, any x squared, that could be 2x squared would look like that. If I had 1x squared, it would look more like this. If I had 1/2 x squared, it would look something like this. And if I had maybe even 5x squared, that would be even tighter, so it would be like that. The main idea here is if I have something x squared, then my end behavior, what happens when I go to my way to the left and what happens when I go way to the right, looks the same. It looks like this. On the left, it's going to go this way in some steepness, and to the right in some way it's going to be going up to the right. Okay, so when I drew my end behavior for this, I'd say, hey, my end behavior is that, meaning ultimately the graph is going to be going up towards the left and up towards the right. With the one below here, negative 3x squared, negative 3x squared kind of looks something like this. And it's kind of the reverse thing of what we were just looking at. If I had negative x squared, it would probably look like that. And if I had negative 1/2 x squared, it would look more like this. And similarly to what we were just talking about, we go down to the left and down to the right. And so my end behavior for this one would be this little drawing showing that as I go far to the left, this graph goes down, and as I go far to the right, the graph goes down as well. Okay, so that's what happens with x squareds. With x squareds, they either both go up, the end behavior is both up or both down, depending on if the coefficient in front of the x squared is positive or negative. Okay, what about x cubed? Well, x cubed looks something like this. That's just 1x cubed. If I had 3x cubed, it would look more like this. If I had 1/4 x cubed, it would look more like this. Okay, and I could do a bunch more. I could do 1/10 x cubed, and it would probably look like this, something like that. But you kind of get the picture. As with x cubed, as I'm going to the left, it's going to be going down. As I'm going to the right, it's going to be going up. And so the end behavior of x cubed looks something like that. Okay, how about negative 2x cubed? You're probably guessing just because of what happened with x squared, and you're probably right. Negative 2x cubed is going to look something like this. And negative x cubed then would look something like this. Negative 1/2 x cubed, something like that, and so on. And so you can see that negative x cubed will be going up as you go to the left and down as you go to the right. So the end behavior would look like this. Okay, how about x to the 4th? Well, x to the 4th looks like this. This is, well, how about 2x to the 4th? You know, it doesn't matter, any x to the 4th. Let's say this is 5x to the 4th. Then this would be 1/3 x to the 4th. Maybe we even throw in a 1/10 x to the 4th. Okay, the end behavior is going to be that it's going up to the left and up to the right. Interesting that that's the same as x squared over on the left. And in fact, when you have any even power, you know, here it's 2, here it's 4, any even power that you have, if that's the highest power, then the end behavior will be up to the left and up to the right. And also with any even power, if the coefficient in front is negative, then the end behavior is going to be going down to the left and down to the right. What we see also here with x cubed, the end behavior for x cubed is going to be the same for x to the 5th, or x to the 7th, or any odd-powered polynomial. So any odd-powered polynomial, the end behavior is going to be down to the left and up to the right, unless there is a negative coefficient in front of it. If there's a negative coefficient in front of it, then the end behavior will be up to the left and down to the right. And it kind of follows that pattern. So how could you apply this? Well, if you just had any random polynomial, you could tell the end behavior, tell what it's going to look like in the long run by looking at this. So if I have y equals, let's go with negative x to the 5th plus 2x cubed minus 7x plus 1. Okay, if I want to think about the end behavior, really the only thing I want to look at is this highest powered term. So in this case, the x to the 5th. And if it's in standard form, it should be the first thing there. So y equals negative x to the 5th. Since this is an odd-powered function, the end behavior you would expect would look like x cubed, but then we remember that there is a negative sign in front, the negative coefficient, so it flips it, and the end behavior for this is actually up to the left and down to the right. That means I know that what this graph's going to look like in the long run is going up to the left somehow and down to the right. That doesn't tell us what in the world's going on in the middle. We don't know, but it does tell us what the end behavior is.